For this project, I will be explaining the physics behind Edward Encarnacion's home run. Assuming that the pitcher is at the origin, the ball is thrown from the origin to the right and has a negative vertical velocity due to gravity. Then the ball is hit by the batter, and the ball still has a negative vertical acceleration. However, it is now moving left with a positive upward velocity and goes way past the origin. Newton's first law states that an object will remain at rest or in uniform motion in a straight line unless acted upon by an external force. This is in play when the pitcher throws the ball. The player throws the ball with a lot of force and it remains in its uniform motion, flying to the right, until the batter hits it with an external force and then it changes in motion. Newton's second law states that the acceleration of an object, as produced by a net force, is directly proportional to the magnitude of the net force, in the same direction as the net force, and inversely proportional to the mass of the object. This law can be applied to the situation of a home run by analyzing the net force acting upon the ball and the force it takes to make a home run, taking into account the weight and mass of the ball. Newton says that an object will only accelerate if it has a set of unbalanced forces acting upon the object. The batter applies a set of unbalanced forces on the ball, and since the net force is greater than the force from the pitcher, the ball is sent out of the park with a positive velocity. Newton's third law states that all forces in the universe occur in equal but oppositely directed pairs. There are no isolated forces. For every external force that acts on an object, there is a force of equal magnitude but opposite direction which acts back on the object which exerted that external force. This law is in effect when the batter hits the ball. The ball is traveling at a very high speed, and when the batter hits it, an equal and opposite normal force is acted upon the batter. The ball still changes direction and flies out of the park, but the batter feels the equal and opposite force from hitting that ball. And that is the physics behind this home run.